Hey, what's up guys? Welcome back to the Mr. Fix-It channel. Today I want to talk about carburetors and carburation. How's it work? What do they do? What's the principles and the science behind it? I may go off on a couple little tangents here, but I'm going to try my best to stay on point. Talking about carburetors. Stay tuned.
I was sitting out there in the shed one evening, not doing too much of nothing, just kind of staring at the wall and...
Alright, so this video is going to be long-winded. All I'm going to be doing is talking. I'm going to be showing you some carburetors, and I'm going to talk about some of the science and some of the principles that are involved and some of the troubleshooting with carburetors and all the differences between the carburetors. So this video is more for the people that want to learn about carburetors and how they work and the operation and yada yada yada. So if this video isn't for you, I don't blame you. Go ahead and skip through it or just go to another video. But I'm just warning you now that this may be boring and I'm going to be throwing a lot of words at you. You'll find carburetors on a lot of machines. ATVs, motorcycles, some of your old cars still around, or drag racing or race applications still use carburetors. And how does this work? How does air travel through here and draw fuel through the bottom, through the jet, and mix into the airstream? Well, we're going to use Bernoulli's principle. Bernoulli's principle says that anytime you take a given volume of air that's flowing at a certain rate and you force it through a restriction, that air has to accelerate, because you're pushing the same volume of air through a smaller orifice, and when that air accelerates, the pressure in that region drops. So then again, atmospheric pressure is going to try to force fuel out of the fuel bowl and up through the jets and into the airstream. So this is called a venturi, and that's basically how every one of these carburetors work, even this Holley 4-barrel here. This works exactly the same way as this. Now, for the most efficient burn, we want to atomize the fuel, which means break the liquid up into tiny itty bitty little drops, not quite like a vapor, more like little tiny droplets. So to help that, the carburetor has what's called an air bleed, and it's usually in the throat on the air filter side of the, this is called the air horn. And on the air horn we see these ports down in here. Now there's going to be a port for the main jet, a port for the pilot jet, and some carburetors have other ports, and we'll get into that here in a minute. But what's going to happen is it's going to draw some air in, and it's going to mix in with the fuel right as it goes through the jet, and you're going to have the fuel mixed with a little bit of air before it goes through the carburetor and into the airstream, and that will help atomize the fuel, or basically just mix the fuel with the air. Okay, so that all being said, how the heck do these things work? Okay, so every carburetor is going to have a fuel source. It's probably going to be like a gas tank, just to be as simple as possible, and every carburetor is going to have a way to let gas in. And see, this lawnmower carburetor here has a shutoff valve right on the carburetor. This is the fuel inlet side. You turn the fuel on, it flows. Every carburetor is going to have a way to meter that amount of fuel so that we don't get too much fuel or not enough fuel. And most typically you're going to have a float. So this is just a box with air in it so that it floats like a boat. And the air will, the fuel will come in. It'll go past a valve, which is this guy right down in there, that moving up and down, and as the fuel floods into this bowl, the fuel will push up on this and it'll close that valve. Some carburetors, like this chainsaw carburetor here, doesn't actually have a fuel bowl per se, but what it does have is a diaphragm in here, and the vacuum created by the engine will the vacuum created by an engine's in a pulse. So every time the piston goes up, it creates a pulse. Every time the piston goes down, it creates a pulse on the crankshaft side. And this chainsaw carburetor uses that a pulse through this tiny port here, and there is a spring-loaded diaphragm in this which meters the fuel. So every pulse you get a pumping action, and that pumps fuel, and on the other side of that diaphragm is where the fuel is stored to be sucked through. Suck technically isn't the correct word. We're talking about changes in atmospheric pressure is what we're talking about. The only thing that sucks really is taxes. So other than this carburetor here, or this style of carburetor, you're going to have a fuel bowl. Now this is off of an old Briggs & Stratton flathead, and the fuel bowl is actually part of the gas tank. So that's why this one does not have a fuel bowl, because it's, you know, the gas tank is part of it. You can see fuel bowl, fuel bowl, fuel bowl, all these fuel bowls. Even this Holley 600 CFM double pumper 4-barrel carburetor, these are the fuel bowls. So if I set this up like this, you can see the similarities there. Now once the fuel enters the float bowl, it's metered by the float and the needle valve. The Venturi effect creates a low pressure. These jets are in that low pressure stream, so the fuel is delivered through the jets. Now here's where carburetors start to differ. Some carburetors only have one jet, like this lawnmower carburetor. So you can barely see it down there because of the shadows, but there's only one jet. Here's your float, and there's your one jet, and it goes directly into the Venturi, or the throat of the carburetor. As in this carburetor, it only has one jet. But as you get into the more performance applications like dirt bikes, ATVs, automobiles, we need more than one jet. So this carburetor is really good at running at a constant speed. As lawnmowers do, they're governed. You basically just turn the throttle up and it holds it at one specific speed, so there's only one. How do I say this? The changes in velocity of air through this carburetor are not going to be as drastic as it would be, say, for a high performance dirt bike carburetor. Every carburetor is going to have at least two circuits, an idle circuit and a main circuit. This carburetor here has two circuits. That's the main. The pilot is actually holes drilled through passageways in the carburetor housing. So if you see this right here, you can see this hole is drilled all the way through, and then you see that brass plug there. That's where they had to drill straight down, and there's a tiny little orifice. It's almost impossible to show you, but there's a tiny little orifice that allows a tiny bit of fuel to go through for idle when the throttle is shut. And then as the throttle starts to open, it starts to transfer from the pilot into the main. So in more performance applications, we add more jets. So in this case, we have the pilot circuit right here, and this is, you can control the amount of fuel by twisting this screw. And then to transfer from idle to just off idle, we have a slow jet. So there's another jet down inside here. So that's the help to transfer between these two circuits. And then to transfer yet again, we have another circuit. This circuit here will be more for cruising speeds, and then when you start to open the throttle up even further, we start transferring into the main jet. As you can see in this carburetor here, this is off of a smaller engine, less performance. We only have two jets. We have the pilot jet and we have the main jet. Now we also have the pilot mixture screw right there, and you can adjust for idle with that screw. So let's talk about the pilot circuit. What I mean by circuit is the path that the fuel goes through, and depending on the amount of throttle opening, so as you open the throttle, you're letting more air in. So the pilot circuit is adjusted here, and this is just for idle speeds. So the throttle is going to be slightly open to let enough air in for idle, and you can control that mixture from this screw. Now if we take a line and divide this carburetor, we can tell if this is a fuel adjusting screw, if it's on the engine side. So the air comes in, vacuum happens, draws fuel. So if it's on this side, this is a fuel screw. If the screw is on this side of the center line of the carburetor, this is an air screw. So the fuel screw, you want to turn counterclockwise to add fuel, because you're opening up that passageway, making it bigger to allow more fuel. Now if it's an air screw, it'll be on the air filter side, and if you turn that counterclockwise, it'll open up the orifice and allow more air to pass through. That's how you differentiate between an air screw and a fuel screw on a carburetor. Even this Holley 4-barrel has the same type of screw, and if you look right there, that's that screw. That meters the amount of fuel for idle. There's one on each side of this carburetor. So most of your performance carburetors are going to have some way to adjust the amount of fuel at idle. So like on this carburetor, that screw would be right there. Yet again, on this carburetor, it's right there. It's on the engine side. That's the air filter side. That's the engine side. So that's a fuel screw. And they're placed in different locations. Sometimes they're on the bottom, like these carburetors. Sometimes they're on the side, like these carburetors. Even this little tiny chainsaw carburetor has that screw, and that's it right there. Now for your more simple carburetors like your lawnmowers, they don't always come with a fuel mixture or an air mixture screw, and it's all done by the jetting. Now this carburetor here is really easy to show you that orifice for the pilot jet. So right there you see that tiny little hole. This is on the engine side of the carburetor, and that's where the fuel will come out of during idle. So you can see that's the adjuster screw, and right inside there is the orifice. So this screw literally screws in and blocks that off or opens that up, and that's how that works. And in this carburetor example, right there, that is the top of that screw. You can see how it pokes through there. The screw is right there. Let me see if I can focus on this. So I'm going to unscrew this. And as I unscrew it, it opens that orifice. Now I'm going to screw it back in. You see it poke through there. This is what you're doing when you're adjusting this screw. You're adding or taking away fuel. Now this only affects idle and the transition off of idle onto throttle. Now when you're idling, the throttle flap is closed. As soon as you open the throttle and you start allow more air to pass through this throttle, you're going to transfer the fuel from this port into another port, and the other port is a little bit further down into the throat of the carburetor. So if I can zoom in on this, right there is that pilot jet sticking through. That's where the fuel comes through when you're idling, and as you open the throttle, there's another set of holes right there. Those holes are for the pilot jet, which would be that jet right there. So just off idle, going very slow, the fuel is going to pull. The fuel is going to pull from those tiny little holes there. You have the same thing in the little tiny carburetors like this too. All of these carburetors here on the bench all use this exact same setup. It just may be oriented a little different, it may be set up a little different, but they all use the same principle. You have a screw and you have a jet. Now these three carburetors here, they're a little different than the rest of these, as in they're more simplified and have less jets. So this carburetor is actually going to pull fuel all through the main jet, and it's just going to use Bernoulli's principle in the amount of throttle opening and how much air is passing through to determine if it's pulling from the idle circuit or if it's pulling from the main circuit. So that these are very simple as far as that's concerned. Okay, so as the throttle gets opened more, we've got more air coming in, so we need more fuel. And that's where these other jets come in. So this carburetor here can be tuned in on several different areas of throttle opening, and it's usually idle, and pilot is usually from idle to about a quarter throttle. And then we start getting into cruising speeds and full throttle applications, which is going to be between from a quarter throttle to 3/4 throttle. And like say this carburetor, this is a mechanical round slide carburetor. So the cable gets attached there and it actually pulls up on that slide to allow more air and more fuel. I'm having a really hard time trying to, one, make this interesting, and two, put as much information in this video as possible. So if this is getting boring, I apologize. If you really want to learn about carburetors, all this information is relevant. So hang in there. Okay, so as the throttle opens, we expose another jet, which is that straight piece going down through the center there. This is called the main metering needle. This is for all your half throttle or roundabouts fuel mixtures, and that is going to be, it's going to be going directly into the main jet. So the main jet is always directly under the slide of the carburetor. Now some carburetors are mechanical slide like this one, which does not have a butterfly flap. Some carburetors are like this one, which has a butterfly throttle and a slide. This carburetor has a vacuum diaphragm on top of it, and if you're a car guy, you can relate this to a vacuum secondary. So as vacuum increases, it will actually draw the slide up. Now the slide is basically just a valve. It opens and allows more air to go through, and on the slide you have this metering needle. If you notice, this metering needle is tapered, so the further this thing slides up, the more fuel can flow past it. So that's how that works. Now on a vacuum carburetor or a CV or constant velocity carburetor, the slide is controlled by vacuum. The same Bernoulli's principle that draws the fuel up through the jets out of the fuel bowl also opens this slide. So we can see we have a hole in a slide right there that allows vacuum into this chamber, which reacts against the spring, and the spring also will close the slide valve. So we have two different types of carburetors going on here. So if we look at this Holly over here, all we have are butterfly flaps, and there's no slide. But a lot of your more modern motorcycle carburetors are going to have both. The carburetor here is also a CV carb, but it does not have a diaphragm. It actually has a solid aluminum slide which creates the seal to move this slide up and down, but works the same way as this does. Now the fuel gets metered by this needle from about half throttle to about full throttle, and just before full throttle this needle is at its maximum. So after that it's basically pulling fuel completely from the main jet. So you have all these circuits depending on throttle opening on where this carburetor is going to get its fuel from. So that leads me into, how do you tune a carburetor? So tuning a carburetor is pretty simple. You just change out the size of the jets. The jets are going to have numbers on them. Unless you buy the cheap eBay Chinese jets, there will be a number on it somewhere. So if you have a bike, it's completely factory, everything on its stock, and the carburetor has been tuned just for that, then the only thing you have to do if you have problems is clean the carburetor, make sure the jets are clean, and you should be fine. Now anytime you go modifying a bike or a four-wheeler or a car, as far as the intake, the cylinder head, the valves, the exhaust. Anytime you change any of that, the carburetor is not going to know what the heck just happened. It's not like electronic fuel injection where the computer has an oxygen sensor and says, oh, we got too much oxygen, we need to add more fuel. This does not know how to do that. You have to be the one to adjust the amount of fuel to reach a stoichiometric ratio of fuel. So this is where things start getting complicated for people, and knowing how to tune the carburetor. Let's say you took the factory air box off, which the carburetor was tuned for, and you put on pod filters. These godforsaken things. So when you take your factory air box and you put this thing on, you have just changed the characteristics of how the air is introduced into the carburetor, and now you have to figure out whether it's running rich or lean and adjust accordingly by putting in different sized jets. And this is going to take some troubleshooting. You're going to have to run the bike, find out if it's having issues, whether it be on idle or half throttle or full throttle, and that's going to be important to know where you're going to start as far as your tuning goes. Now, as far as these filters go, a lot of times they have that lip inside there, and on a CV carburetor especially, because you're going to see these more often than any other carburetor, they have this port right there. Now a lot of this one here has the port kind of back in there a little ways, whereas this carburetor, you can see the port is flush with this. And if you go to stick this air filter on there, that little lip inside the air filter is going to block off that port, and it's going to cause you problems. So keep that in mind. You may have to modify your carburetor to run a filter like this. Now on your mechanical carburetors, the ports are all usually in the air horn, so you don't really have that much of an issue. But on the CV carburetors, let's go to this one. So you have the air bleed. Remember how I was talking where the air needs to mix with the fuel before it goes into the throat of the carburetor to atomize correctly? Well, the air bleed in this carburetor is underneath the slide diaphragm right there. So if you block that port, you're not going to get the correct amount of air flowing in to atomize the fuel correctly. So whenever you go to changing things on your air intake, you're going to be tuning your carburetors. That also goes for if it's a 4-stroke and you just put a bigger camshaft in it, it's going to draw air differently than it did that the carburetor was tuned for, and you're going to have to tune for that application. Same thing goes for exhaust. You would think, well, it's on the other side of the engine, how's that affect? Well, the exhaust is allowing, if you put a better exhaust on your engine, it's going to what's called scavenge better, which means it's going to empty the cylinder of all the exhaust gases more efficiently, which means you're going to have more air entering the cylinder because you have more volumetric efficiency, which means you need to add more fuel to that. So depending on where in the throttle position you're having your problems at, it's going to tell you which jet you need to change. So if it's idling poorly, you can try adjusting this screw. If it's idling good but just off idle, it's running bad, then you change the pilot jet. Then you'll have to readjust this screw for the new pilot jet. And then this could act as a domino effect where you go changing this jet, you go to change this, now all of a sudden this jet's wrong. When you're tuning carburetors, you're going to pull the carburetor off, you're going to do a jet change, and when you're doing changes in your jetting, you only want to change one thing at a time. Because if you change multiple things all at once and you go out there and ride the bike and it runs just absolutely horrible, you're not going to know which one of them things did it. It could have been a combination of all of them or just one thing. So just change one thing at a time. If you're having problems with the pilot circuit, just change the pilot jet. Put it back on the bike or the quad or whatever it is and go for a test ride. This is going to be time consuming. You might have the carburetors off several times, but just stick with it and you will get it tuned. And just real quick on tuning carburetors, you're not going to have a computer telling you if it's rich or lean. you're basically going to look at the spark plug. If this is all black and sooty, that's too much. So what you can do is called a throttle chop. So you take the bike down the road or down the trail or whatever you're doing, whatever you're riding, and you get the throttle in the position that it's having a problem, where it's bogging or whatever, and you want to hold it there for a length of time for as long as possible, and then you're going to shut the engine off without moving the throttle. And then you'll pull the spark plug. And you'll read the spark plug. If it's all black and sooty, then you know it's got too much fuel in that range of throttle. If it's white and crusty, looks like it's burnt, then it's not enough fuel. So that'll help you in your tuning by looking at the spark plug. Okay, all these carburetors have passageways and ports. You can see there's a passageway there, there's a port there, there's a port there, there's ports in there, there's ports all over this thing. And if you kind of look at the carburetor body, you can kind of get an idea of where these ports are going. So if you see this section here, how it looks like a tube, there's two tubes right next to each other. Well, if you look down in there, what do you got? You got two holes. And if you follow them, now you can see how there's like a, looks like a brass BB stuffed in that. That's where in the machining process, when they drilled this hole had to change directions and go down inside. This one goes to the emulsion tube. The emulsion tube is where the air and fuel mix before it goes into the throat of the carburetor. So you can follow this, and you can see they had to change directions, so they physically had to drill this way, and then they had to drill this way. So you'll see a plug where they had to drill that carburetor, and you can kind of get an idea of where that port is going by following it. Hold on, let me take this float out so I can show you. Alright, so we're looking at the one on the right there with the brass jet in it. So if we follow it down, we can see where they had to drill, and then they plugged it off, and then there's that same port going into the emulsion tube of that jet. So one of the biggest things you can do to helping the performance of your carburetor is to make sure that it's clean. And a lot of people only think about this area of the carburetor, but you have all these passages in here. So as you look at this carburetor, you can see there's a port right there. So let me get this in the light. There's that port right there. You can see how it travels through the carburetor. See how it had to change directions. They can't drill around corners, so they had to come in from that way and drill in that way. And then there's a plug, and then they drilled down in that way to get down into there. So you can kind of look at how everything is mapped out on the carburetor just by looking at the carburetor, and you want to be able to clean all these passageways out. Just like this port right here. This is the vent. Now let's talk about the vent for a minute. Now we talked about how the atmospheric pressure is forced into the float bowl and then pushes the fuel up into the throat of the carburetor. Well, in order for that to happen, it has to be vented to the atmosphere. So that allows the atmospheric pressure to enter the float bowl from outside the carburetor, and it's also vented underneath the slide diaphragm, and it's vented, it comes out in that hole right there. There's also one on that side. You can see how if you follow that passage up, there's that other port right there. So you can map out how these circuits flow through this carburetor if you just look at it really close and understand what you're looking at. All the ports in the carburetor. See that nipple there in this carburetor? Since this is on the engine side and it's on this side of the throttle flap, we're going to have a high vacuum on that side, and that right there is a vacuum port for, say, your vacuum petcock. We also have these types of ports on this Holley 4-barrel for a car engine. This is a vacuum port. The vacuum's on this side of the carburetor, and there's ports and channels that lead up to this hose to run vacuum controlled items on the car. So you can see, even though these carburetors all look very different, they are all very similar. So this carburetor here, see that as a vent tube. It goes down into the float bowl. There's another port there, another port there. So maybe this will help you get an understanding of what you're looking at and why the carburetor looks the way it does. Okay, other differences in carburetors. So all these carburetors here are all basically simple mechanical carburetors, and you either are going to have a choke or an enrichener. Now this carburetor here, the choke is actually in the air box, so I don't have one to show you, but this carburetor here, we can see that is the throttle, and on the other side we have a choke. And what the choke does is it closes off the air and allows the engine vacuum to suck an extra amount of fuel out to get the engine started when it's cold. Because when air is cold, it has more oxygen molecules packed in the same volume than air that is hot in the same volume. So we need more fuel for startup. So this old carburetor here, this is the choke, and it actually blocks off the throttle throat right there. This carburetor here has a choke here. The flap is missing, but that's the choke. Now when we move on to carburetors with enricheners, they call this a choke, but it doesn't actually choke off the air. What it does is it opens up a port and allows more fuel to flow through. So that carburetor there, that's where the enrichener goes. And some carburetors are going to have a throttle position sensor. Now you're thinking, well, isn't that for electronic fuel injection? Well, some of the more modern carburetors are going to have a throttle position sensor. Like this carburetor here had one on that side of it. What this throttle position sensor is going to do is it's going to retard timing or advance timing depending on throttle position. So if we go back to stoichiometry for a minute and we talk about the most complete burn we can get out of our fuel for the most power and efficiency, we want to talk about the dynamics of how the fuel is burnt inside the engine. And what I'm talking about is if you have a really lean mixture, let's just say idle is usually pretty lean, and there's less fuel in the given volume. Once the fuel and air is compressed and the spark goes off, that spark starts a chain reaction that leads from one fuel molecule to the next, and it takes a certain amount of time for when that spark goes off till all that fuel ignites to create the pressure to push the piston down. And this is where we start talking about ignition timing. So when you have a lean condition, say like at idle, you want your spark advance to be way ahead or advanced, because it takes longer for that fuel to burn and create pressure. Now as you open up the throttle, and say if we get to wide open throttle, you have a lot of air and a lot of fuel entering the engine, and when you have a lot of fuel tightly packed, it takes less time for all that fuel to ignite and create the pressure. So we want to decrease timing or retard timing so that we don't get pre-ignition. And pre-ignition is basically where the fuel ignites before the spark plug ignites it. So the more fuel you have, the less timing advance you need. So carburetors that have a throttle position sensor will detect the amount of throttle and send that signal to the ECM, and the ECM will adjust timing based on the throttle position. So if you're at idle, it's going to advance the ignition timing, and when you whack the throttle wide open and it dumps all that fuel in there, it's going to retard the ignition timing so that you don't get pre-ignition. This is going to optimize the performance of the engine with this combined with the ECM. Other differences in these carburetors were this carburetor here does not have an accelerator pump, and an accelerator pump looks like this. They're all pretty common in their shape, and they're all kind of off to the side. They all have a rod sticking out which gets actuated by the throttle lever. And what that does is when you whack the throttle wide open, all of a sudden you get a sudden rush of air, and the carburetor needs a second or so, or some given amount of time, to allow enough fuel to mix with that air. So what we do is we add a pump on here so that it squirts a stream of fuel into the engine right as you open the throttle, so you don't get that bog that you get when you whack the throttle wide open. Now these more mechanical carburetors are pretty good at mitigating that bog, but you still can't get that bog. So that's why they have an accelerator pump. Now, yet again, even on this car engine, we have an accelerator pump, and that is right there, and it's actuated by the throttle. So you can see the similarities in these carburetors, even though they're all completely different. And some carburetors, like Honda likes to do this, they have what I would refer to as a power valve, which is actuated by engine vacuum. And when we talk about engine vacuum, when you're idle and that throttle is closed, there's a lot of vacuum there. But as soon as you open that throttle and air starts to flow into the engine, the vacuum will go away. So at wide open throttle, you should have, ideally you would have zero vacuum, but it's not always zero. If it's not zero, then you have a restriction in your intake somewhere. But that being said, this power valve is actuated by the vacuum. So when the engine is idling or at a low speed, there's a lot of vacuum which pulls on a diaphragm, and it's spring loaded, and it keeps this valve shut. But as soon as you open the throttle wide open, this vacuum will release this valve and allow more fuel to enter the carburetor. So that's what that is on the side of your carburetor. That is actually a power valve. It's not real common, so this is the only motorcycle carburetor I have that has a power valve out of all these carburetors. Now this Holley has a power valve, but it's internal. I won't be able to show it to you, but it works the exact same way. When engine vacuum goes away because of wide open throttle, it will actually allow more fuel to enter the engine. Alright, some engines are only single cylinder, like this Yamaha engine over here. It's only got one piston, so we only need one carburetor, one barrel. A lot of your Japanese motorcycles that have multiple cylinders will have multiple carburetors all set up on a bank. Well, these carburetors are froze up, they've been sitting out in the weather, but it has one cable that actuates all four carburetors at the exact same time, and they have to be synced together so that they all open at the same time. But on other motorcycles, which I don't have one here, but Harley Davidson motorcycles have two cylinders with one carburetor. Okay. Car engines, like this carburetor is primarily for a V8. It has essentially four carburetors in it. This is called a 4-barrel, and all 8 cylinders get their fuel from these 4 barrels of this carburetor. So this is what you call a 4-barrel. There's carburetors out there that are only 2 barrels, which is of course only half of this. It would be this half of it, so 2-barrel, 4-barrel. Some carburetors, twin cylinders, some twin cylinder motorcycles will have carb set up like this, where there would be 2 carburetors. That's why this rod's so long, because there's actually another carburetor that gets bolted onto the side beside this one. So that's basically how carburetors work, a little bit of the science behind it, the physical location of components on the carburetor, how to tune carburetors. Let's get into what happens if it just doesn't work. So everything is normal, everything's fine, all of a sudden your engine starts to run poorly and you suspect it's the carburetor What could it be? If it's a very simple carburetor like this, most commonly what's happened is you've had some debris in the gas tank work its way into the carburetor, and it blocks one of these jets. That is the most common issue with any carburetor, is debris clogging the jets. So everything's normal, everything was running fine, all of a sudden it starts running bad. Pull the bowl off, clean the jets. There may even be some sediment in the bottom of the bowls. Just clean all that stuff out of there. Now, other problems you may have in this type of CV carburetor where you have this slide diaphragm is this rubber boot. It could be old. It could have been damaged from weather cracking, and there actually is a leak, and this throttle slide just cannot open because it can't create the vacuum it needs to open. So you want to inspect this rubber diaphragm for any tears. This is another big common problem, especially with CV carburetors, is this vacuum diaphragm. Or say you took the carburetor apart to clean it and you put it back together and it wasn't running right. This has to seal along this lip, and if this gets put together with that lip like that, it's never going to run right, so check that. Other problems is where the gasket is on the float bowl. If that's leaking, what that's going to do is it's going to cause a high speed lean condition, because it's going to want to draw air through the seal instead of pull the fuel out of the bowl. So if you notice any varnish or anything leaking around this seal, you need to replace this gasket, because that needs to be sealed. If you have a carburetor with an accelerator pump and it seems to bog when you stab it into the throttle, then you need to inspect the accelerator pump. There's a diaphragm, a spring, a check ball, there's a rod that actuates it, and a lever on the throttle. You need to inspect all those things, and they may require adjustment. If everything was fine before, then adjustment may not be it. It's probably debris, more than likely, or the diaphragm got torn, spring broke, any of those things could happen. Vacuum leaks at the engine intake rubber boot. This thing. If air is leaking past this thing, then there's going to be air entering the engine without the proper amount of fuel going through it. Now, if you had if you had an elf or a fairy squirting fuel into that vacuum leak, then you're fine. But yeah, that's not happening. So you need to check for vacuum leaks on the engine side of the carburetor and intake manifold. That's called pirate air. That's air entering without being metered by the fuel coming out of the carburetor. You can usually check that by starting the engine up and squirting some type of flammable, combustible liquid onto this boot, and if the engine RPM changes, then you have a leak here. If your air filter got a hole in it somehow or was disconnected, you could be blocking up these ports, these air bleed ports. That could cause a bad running condition, so you want to inspect all those ports. Usually when I clean a carburetor, I'll get a can of, I use brake clean, because carburetor cleaner is good at cleaning carburetors, but if there's any rubber parts around, the carburetor cleaner may damage that rubber. So I use brake cleaner with this straw in here, and you can get down inside those ports, and if you have the carburetor completely disassembled, you'll be able to see the liquid coming out of the other side of that port, and that'll let you know that the blockage has been cleared. So if the engine has been increasingly running worse and worse over time, you may check to see if this slide needle is worn, because this thing is rattling around inside that jet, and that orifice that the slide needle goes into, that guy right there in the center, that can get worn out and allow too much fuel to pass the needle, causing a ridge condition. If you have a carburetor with a enrichener circuit like this is basically just a plug that plugs up this port here, and if that becomes worn, it will actually allow air to flow through and past this and into the into the engine without any fuel being mixed with it, and it'd be the same thing as a vacuum leak. So if you're having a lean condition, especially at idle, I would check this to make sure that it's tight and fits snugly in that bore. Vacuum leaks are going to show up at idle. The bike will be hard to start, it won't idle correctly, it may pop and crack on deceleration. Those are characteristic signs of a vacuum leak because you have more vacuum at idle than you do at wide open throttle. So if it's a vacuum leak, it'll run poorly at idle, but it'll run good at wide open throttle. So that's typically a vacuum leak problem. If it's running lean at wide open throttle, then it could be a plugged main jet, or this slide's not opening in your CV carburetor. If that don't open, you're not going to have full throttle. So on these carburetors with this butterfly valve, you can also have a vacuum leak past that shaft that turns. So if you're having a vacuum leak you just can't figure out, it may need new seals in that butterfly shaft. These carburetors, if that slide gets worn too bad and it's actually loose in there, you'll actually get air leaking past the slide. So that's another place you can look for a vacuum leak. Alright guys, I know that was boring and tedious, and I could literally go on for hours about these carburetors and how they work, but hopefully I covered the more general aspects and kind of give you guys a better understanding of how these carburetors work and what they do. So I think I'm going to end this here because this video is already long. It's probably going to be boring, but if you like this video, please give me a thumbs up. Consider subscribing and don't be afraid to fix it. Thanks for watching.